Hi pre-calc peeps. Today we're going to continue on with our triangles and we are going to look at the law of cosines. Now, you can find the proof of this in your textbook. It is derived from the distance formula. However, for time purposes, I'm going to go ahead and give you the law of cosines formula. We can say that the side a squared equals b squared plus c squared minus 2bc cosine of alpha. Likewise, we can say that b squared equals a squared plus c squared minus 2ac cosine beta. And we can say that c squared equals a squared plus b squared minus 2ab cosine gamma. Just like when we were dealing with law of sines and there were certain scenarios that we used law of sines for, the same is true for law of cosines. The first thing we're going to look at is when you are given two sides and an included angle. For example, let's take a look at numero uno. I'm going to give you beta, which is 75 degrees. I will give you side A, which is 7, and side C, which is 5. So, just like what we did before, we're going to set up our triangle. Insert in the given information. And we will use the law of cosines to find side B first. So we can set it up that B equals, well, that is A squared plus C squared minus 2AC cosine of beta with a big old square root of that entire thing. Type that guy into your calculator, take it to 1 or 2 decimal places, and you get 7.48. From here, if you wanted to, you could continue with law of cosines, but you totally don't have to. In fact, we can jump to law of sines to find angle alpha or angle gamma. It is best practice for you to always find the smaller angle first. In this case, the smaller angle is going to be gamma because gamma is across from 5 and the smaller angle is always going to be across from your smaller side. So we have 7.48 over the sine of 75 equals 5 over sine gamma. You can cross multiply, divide, take the inverse sine, and when you do that, we get that gamma equals 40.2 degrees. From here, if you wanted to, you could do law of sines again, but since we know the sum of all triangles adds up to 180, we can do 180 minus 75 minus 40.2, and we can get that alpha equals 64.8 degrees. So, we have our answer in that we have B, gamma, and alpha. Now, go ahead, take a second, try example 2, following example 1 that we just did. Pause the video and come back once you have all the answers and let's check them. I'm giving you alpha as 19.2 degrees, B as 8, and C as 6. Set it up, give it a try, come back and check your answers. Okay, so let's check. Setting up my triangle. Here's 19.2, making that side A. There's 8, so that's beta. There's 6, so that's gamma. Solving for side A, I get A is the big old square root of 6 squared plus 8 squared minus 2 times 6 times 8. Why did I write 6 again? Erase. Let's try that again. Times 8 times the cosine of 19.2. And you get that A should be 3.06. Jumping over to law of sines. Remember, you have to find the smaller side first. In that case, that's going to be gamma again. So we're going to say that 6 over sine gamma equals 3.06 over the sine of 19.2. Cross multiply, divide, inverse sine, and we get that gamma equals 40.2. Finding beta by doing 180 minus alpha minus gamma, we get that beta equals 120.6 degrees. Now, if you were to have tried to use law of sines, you would not have gotten an angle of 120.6 degrees if you had done 8 over sine beta. That's because the principal values of inverse sine go from negative 90 degrees to 90 degrees. So inverse sine on your calculator will never give you an obtuse angle. That's why you have to find the smaller angle first and then continue on to solve for beta using the other triangle addition that we've been using. Okay, now let's move on to talk about the second type where we use law of cosines, and that is when you are given 3 sides. Numero uno, I'm going to give you that A equals 3.4, B equals 2.7, and C equals 1.3. So let's set up our triangle, and I have 3.4 alpha. We can go 2.7 and beta, and 1.3 and gamma. To solve for an angle, we're still going to set it up in the law of cosines formula that we've been using. I'm going to say that 3.4 squared equals 2.7 squared plus 1.3 squared minus 2 times 2.7 times 1.3 times the cosine of alpha. Sorry for running out of room on the right side there. When you solve for cosine of alpha, we're going to take 3.4 squared minus 2.7 squared minus 1.3 squared. Then we would divide by the negative 2 times 2.7 times 1.3, and that would equal the cosine of alpha. So to solve for alpha, you'd have to do the inverse cosine. I don't know why I wrote squared. The inverse cosine of your big old parentheses here of 3.4 squared minus 2.7 squared minus 1.3 squared over negative 2 times 2.7 times 1.3. And you should get that alpha equals 111.56 degrees. From here, you can set up using law of sines to solve for alpha or beta. Now, not alpha or beta, beta or gamma. Since alpha turned out to be our obtuse angle, it doesn't matter which one you pick. However, keeping with the best practice of doing the smaller side first, I will solve for gamma. And in doing so, cross multiply, divide, inverse sine, we get that gamma equals 20.83 degrees, and then we can solve for beta by doing 180 minus alpha minus gamma, and we'll get that beta equals 47.61 degrees. You're probably wondering, Ms. Gutierrez, you keep changing how many decimals you go to. Guys, 1 or 2. I don't know what to tell you. Just go 1 or 2. I know I'm all over the place. Bear with me. All right. One more. why don't you, again, try number 2, pause it, come back, check your answers when you're done. A equals 4, B equals 7, C equals 10. Give it a shot, come back, check your answers. There's my triangle. Always looking the same. 4, 7, 10. Alpha, beta, gamma. In this case, again, I will just solve for alpha first. Following what we did before, alpha equaled the inverse cosine of, it was a squared minus b squared minus c squared over negative 2 times b times c. That gave me that alpha was 18.2 degrees. Setting up law of sines, solving for beta. 7 over the sine of beta equals 4 over the sine of 18.2. Gives me that beta equals 33.1 degrees. And then solving for gamma by doing 180 minus alpha minus beta gives me that gamma is our obtuse angle of 128.7 degrees. So, hope you're familiar with law of cosine. Bring this to class next time we meet, and we will do more practice with this. And don't forget to study for your law of sines quiz. Have a good day.